Okay, so let's actually go through a problem calculating the confidence interval for proportions in an actual sample. So, let's say we surveyed 326 teens, or an N size then of 326, in Hawaii, and we found that 65 reported having used marijuana. Okay, from there we can calculate a proportion. This is again our observed proportion from the sample. Okay, our overall population is we're trying to understand how many teenagers in Hawaii have used marijuana. Too hard to survey every teenager in Hawaii. So we took a sample of 326. Okay, if 65 reported that they used marijuana, then to get your proportion, you just take that 65 and divide it by your N size of 326. And you get 19.9%, or a proportion of 0.199. Now remember, now we have to get a standard error. Okay, so the standard error formula for proportions is you take your observed proportion of P times 1 minus P, divide it by your N size, and get the square root of that entire equation. So the way that looks is you have an observed P, or proportion, of 0.199 times 1 minus 0.199, which is 0.801, and divide by 326. Now when you do that, you get a really, really small number. Okay, but when you get the square root of that entire equation, it gets a little bit bigger. Okay, it's still a small number, but the standard error ends up being 0.022. So now we're going to take that standard error of 0.022 and put it into the confidence interval formula. So again, for that, we're going to take our observed proportion and then add and subtract your z-score times the standard error. Okay, so if we're looking at a 95% confidence interval, we take our observed proportion, which is 0.199, and then we'll add or subtract 1.96, okay? That's your z-score for a 95% confidence interval times 0.022, our standard error. So 0.199 plus or minus that product of 0.043. If you subtract 0.043 from 0.199, you get 0.156. And if you add it to 0.199, you get 0.242. Now those proportions can be converted into percentages. Okay, and you can see those there, 15.6% and 24.2%. And that is your confidence interval. Now let's explain this in narrative form, which you will have to do on your exam. So, based on our sample of 326 teens, we are 95% confident that between 15.6% and 24.2% of the population would report having used marijuana. Okay, we can see how representative that sample of 326 is for a broader population. Now let's figure out a 99% confidence interval. For that, we just change the corresponding z-score. Now, if I ask you to calculate a 99% confidence interval, only one thing changes. Okay, the process, the formula still stays the same. You take your observed proportion of 0.199 and add or subtract the product of your z-score, which in this case now is 2.58, times 0.022 of your standard error, right? The standard error stays exactly the same. Again, the only thing that changes is the 2.58. That's why there's that arrow above it, which corresponds with a 99% confidence interval. So that ends up being 0.199 plus or minus your product of 0.057. 0.199 minus 0.057 is 0.142, and 0.199 plus 0.057 is 0.256. So you have a confidence interval between 14.2% and 25.6%. Okay, now let's put that into narrative form. Based on our sample of 326 teens, we are 99% confident that between 14.2% and 25.6% of the population would report having used marijuana. That's how you calculate a confidence interval, how you express it in narrative form. And that's what you have to be able to do for your exam.